Area between curves. I hope you enjoyed today's lesson. Let's now talk about the area between curves. Consider two continuous functions from x equals a to x equals b. So they're continuous over the interval from x equals a to x equals b. And we want to find the area between the curves. So if this top curve here is g of x and this bottom curve here is f of x, what we're looking for from a to b is the area between the curves. In other words, we want to know what the area between g of x and f of x is. It's that blue region here. Well, we can find that region by considering that this is the area under g of x. Anything from here down is under g of x. And if I consider this f of x, anything under f of x is here. So perhaps you can see that if you take the area under g of x minus the area under f of x, you'll be left with the area between the curves. From a to b, we can make an expression like this. If I integrate from a to b of the one on top, which happens to be g of x, minus the one on bottom, the curve on bottom, which is f of x, I have to integrate those with respect to x. So there at the top is my expression for the area between two curves. Let's now do an example of finding the area between two curves. In this example, I'm asked to find the region enclosed by the curves g of x equals x plus 1. We know that's linear with a y-intercept of 2. I've drawn a sketch here. Here's g of x. And f of x equals x squared plus x minus 2. We know that that's going to be a parabola that opens up. In other words, it holds water. And here it is. I've drawn a sketch of that as well. The lines x equals negative 1, that's a vertical line here, and x equals 1, that's a vertical line here. Well, we have to know that we're going to take the integral now of negative 1 to 1. There's our lower boundary and our upper boundary. Of what? Well, it's going to be g of x is the top function, g of x minus f of x, all with respect to x. So we put a dx there. The top function minus the bottom function. Notice it doesn't even matter that part of our function, our lower function, goes below the x-axis. When I find the area of f of x, I'm finding this little block here and this little block here. It's the area trapped between our curve and the x-axis. And when I find the area under g of x, I'm talking about this block here and this block here. So even if one of our curves goes under the x-axis, we don't have to worry about it. Our formula will still work. I'll still have the area here, and I'm going to have the area here. We'll see how that works out. If I go from negative 1 to 1 of g of x minus f of x, I can write this as negative 1 to 1 of g of x is x plus 2 minus f of x is x squared plus x minus 2, all with respect to dx. Now, I could integrate these all separately, or I could simplify before I integrate. 1 and negative 1 of, this will be x plus 2 minus x squared. If I distribute out this negative, I'll have minus x, and one more time I'll have plus 2, all with respect to dx, will give me 1, negative 1 to 1 of negative x squared plus 2 and plus 2 is plus 4, all with respect to dx. Now all I have to do is find the definite integral of this. We know, you should know by now how to find the integral of this. It's fairly straightforward. That will equal to negative, that constant will stay there, x cubed divided by 3 plus 4x. And I'm going to evaluate that from negative 1 to 1. So in our last step here, I was running out of board space, so I went to the top. This is what I got for my integration. I'm integrating from negative 1 to 1. That means I plug in the 1, negative 1 cubed over 3 plus 4 times 1 minus whatever I got here is negative 1 cubed over 3 plus 4 times negative 1. Now you have to evaluate this and this separately. Make sure you keep track of your negative signs. And ultimately, we're going to wind up with the total area equal to 22 over 3. Now, why does this work? Well, look, we've got g of x, and when we find the area under g of x, I get this here. So if I'm integrating from -1 to 1 of g of x minus f of x, all with respect to dx, look what we're doing. The area under g of x is right here. Again, why does this work? Well, if we're integrating g of x minus f of x, the area under the curve of g of x is right here. It's this and this. The area of f of x is this and this. If we take the opposite of that, that will give us positive values for these that are under the x-axis. Well, if I take this and the opposite of that, that gives me 1, 2, 3, 4. The four little blocks together, which is the total area, which is 22 over 3. And I don't want to get sloppy. We're talking about square units.